This is where the player begins their journey. As a mushroom apprentice named Mushy, the player finds themselves within the dungeon entrance to the Celestial Temple. In the midst of Mushy's graduation exam, the goal is to prove to their educator that they are worthy of mage status and find Fira, their childhood friend that has been kidnapped by the infected fungi plaguing the temple. In order to produce the level Blockout, I utilize Unreal Engine 5's built-in starter pack for certain assets, physics, animations, materials, geometry brush shapes, and FAB. I also took to tutorials teaching me how to convert assets into blueprint classes and converting audio into sound cues, adjusting their spatial radius and attenuation. The gameplay consists of interactive elements such as left click for shooting projectiles, right click for picking up notes, E to pick up keys and open and close doors, shift to run, and simply walking into items to obtain them, promoting interactivity for the player overall. New inputs were created manually as data asset input action files. After entering the entrance hall, the player can see the featured elevation and height differences, taking the form of vantage points and stairs. Games designer Tommy Norberg defines vantage points as an elevated spot that gives a clear view of things in front of the player. This can be for the purpose of examining the environment before them or to pre-plan enemy battle strategies. The use of verticality and avoiding a simplistic linear space also gives guidance and direction to the player according to Norberg. After defeating the enemy and entering through the door, an occluder corridor is present, which Norberg defines as a space that is purposely designed to be a buffer zone between two areas and break sight lines. I knew that it would be important to take care when it came to occluder corridors. This is due to the fact that there is potential for angled weak spots which can be abused to create power positions, according to Norberg. For example, if the player is allowed to utilize projectiles, they have an advantage against enemies depending on where they stand in the occluder corridor, and there is a loophole in the intended difficulty of the gameplay. One game that this loophole is made extremely apparent in is Dragon Age Origins. The final door through the occluder corridor is locked, so the player assumes the key must be in the library and must backtrack in order to keep the momentum in the gameplay going and remain content efficient. Norberg advises that finding new ways to traverse the environment is a solution to avoiding an artificial room hallway room formula. This was something that I was inclined to agree with. I aim to create a unique move that saves time for the player and avoids repetitive, boring movement. By pressing W, Shift, and left clicking at the same time, the player is propelled further into the environment. Similar mechanics are utilized in many mainstream games, such as Kingdom Hearts 3's air stepping ability and Overwatch 2's jump ability. In particular, the FAB assets that influenced my project most consisted of the mixed VFX and medieval dungeon packs. The aesthetics of the level was aided by the medieval dungeon, and I was able to execute my creative vision with torches, swords, candles, and so on. After unlocking the door leading into Section B of the game, the player finds themselves in the towering ancient library of the Celestial Temple, with pieces of lore scattered around the space in the form of interactive notes. The player learns that the temple was built by the very first mushroom magus to practice their magic, and passed on to the Great Mushroom Wizard, who taught many of the Great Mushroom apprentices. According to Hench, Walt Disney observed that people move towards things that are inviting, and he coined the term weenie to refer to such things. Lilford goes on further to describe weenies as large, visually compelling structures that would pique curiosity and draw people towards them to investigate. Wanting my game to feature the narrative significance of the Great Mushroom Wizard, I decided to utilize a hooded statue asset, drawing the player's focus towards him and following Norberg's negative space teaching to highlight his silhouette. This makes him highly salient, according to Bellard's talk on spatial cinematography, which she explains as, the player is in control of the camera, but we control the environment the player moves through, so we can still control what is on screen by controlling the environment. Bellard additionally touches upon saliency, also known as something which attempts to capture the player's attention. In this context, the Great Mushroom Wizard is an example of top-down saliency, due to the fact that what he represents and symbolizes for all magical mushroom folk is meaningful. After finding the key laying at the Great Mushroom Wizard's feet, the player is then under the impression that the main path is back in the entrance hall of the temple, and is required to backtrack through the map to the entrance hall's occluder corridor. They ultimately find out the segment was a bait and switch, which Norberg states lures the player with a bait, often a fake goal, then reveals the new goal that maybe was there all along but hidden. So whilst a denied affordance is present in the form of dead ends, they have been rewarded with the key to exit the ancient library, progressing their gameplay. To combat any dead end fatigue, I ensured I sporadically included coveted pickups like gems and chests to keep the player on their toes. Krishock defines an affordance as the properties of an object that define its possible uses, such as keys and doors featured in my Blockout, making it clear as to how they can and should be used by the player. On the flip side, Bellard describes misperceived affordance as an object that looks like it does something but actually doesn't, such as the scattered papers on the floor, books, and buckets. This incentivizes my player to continue with their exploration until they find objects and routes that can be used and pursued. Misperceived affordance is similar to the level design book's definition of gates, where anything that blocks the player's movement is functioning as a gate. Blocked off rooms and routes from the rocks in the section are seen as gates, as well as the locked doors. After unlocking the door, the player is met with an apparent funnel where the space is, according to Norberg, made tighter and tighter and then revealed. This is to build up a sense of tension, excitement, and to showcase how the player's journey has led up to this moment in a narrative sense. I additionally wanted to showcase just how small Mushy was, and how, despite being so small, they could achieve great things. By travelling up from the ancient library, the player has two optional paths they can take. They can either defeat a pre-boss within the Hall of Magic and obtain an exotic weapon that levels them up to take on the final boss, the main path, or alternatively, they could skip straight to Section C for the final boss battle, the desired path. It is important to note that once the player has made their decision, they are gated in by a cutscene. Leading up to the pre-boss battle, these side rooms consist of low-intensity gameplay, where the opportunity for the player to enjoy idle animations, save their game, take a breather, mentally recover is present. Meditative spaces are known to be vital for the pacing of a game, aiding in keeping the momentum going, and are somewhat akin to vistas. To paraphrase Majmada, a rewarding vista, coined by designers at Valve, is described as attracting players to linger on a cliff or bench to look at interesting and unique environments. The Blockout consists of unique shapes if the player looks up at the ceiling from a certain angle or down at the floor, with subtractive geometry shapes helping me to achieve unique corridors and pathways. In order to theme my game space, I refer to both celestial and fantastical symbolism, such as sparkles and stars, the sun, the moon, and the Amanita muscaria mushroom. However, in the pursuit of blocking out unique shapes, my virtual shadow map pool overflow had caused extreme lag in the editor viewport. I experimented with engine scalability settings by toggling post-processing and shadows to low, where the frame rate improved significantly but sacrificed the quality and immersion that came with the lighting. The built-in Google AI recommended that I change my shadow map method from virtual shadow maps to shadow maps. As a result, my work would then consistently crash, and I was unable to even load up my project to fix the error. I then had to enter the default engine.ini file and change the rshadow virtual enable equals 0 line of code to a value of 1. I then built the lighting in the viewport and changed from virtual shadow map to shadow map. FPS improved but was still laggy and consisted of frequent crashing. I then opened a backup file and changed all of the lights' attenuation and source radius to lower figures. This seemed to have fixed the lag issue quite a bit, so I continued to work on my project from this file. This final boss battle takes place in the ballroom of the Celestial Temple, linking to Totten's study of staging space where an event occurs. Upon defeating the boss, there is an exit revealed to the player, serving as a transitional path out of the temple. Using game designer Robert Yang's whiteboard test as a reference point, I knew from the get-go that my gameplay had to consist of a balance when it came to structure and complication levels. For example, the floor plan could not be too linear nor too zigzagging. I also attempted to include fake junctions, rounded rooms, as well as angle variations for more variety. The mixed VFX pack also aided me immensely with projectile blueprints, as well as getting to grips with construction scripts, event graphs, variables, and functions. For example, a problem I faced was my sparkle projectile colliding with my enemy to knock them over. I took to Google, Unreal forums, and YouTube tutorials for any aid. I then figured out that applying enemy materials to a static mesh cube would help to knock it over with the first person by utilizing physics and gravity in the engine. I then figured out that using Unreal Engine 5's pre-built blueprint for a projectile and copying and pasting it into my sparkle projectile blueprint might work, to which it did. My enemy could now be knocked over by projectiles. Throughout the blocking out process with geometry brushes, however, I found multiple instances where Z fighting had occurred, sometimes invisibly, and cut off chunks of wall and floor within my level. After extensive research and experimentation, I could not find a permanent singular fix for this. However, I found that rerouting my corridors, changing my shape sizes in terms of width and height, height, and extruding faces did work on many occasions. Remaining consistent with these shapes throughout the whole process was extremely finicky and required multiple attempts to get exact vertices and faces to align.